let's consider a simple question. How can we solve matrix equations? I think the decomposition or transformation are quite complicated. It requires some mathematical background. However, if you do not want to use it in that way, what you need to do is know how to solve the problem with Matlab functions to decompose it into certain forms. So you do not have to know the details of mathematics. Just know how to solve the problem in Matlab. That's enough. And for this section, we will talk something about matrix equations. And we will start from the simple equation such as A times X equals to B, how to solve it. And also for control-oriented problems, we need to discuss something like Lyapunov equations or parametric equations. These are all linear equations. And also for projective equations, we have these equations. So we can discuss how to solve matrix equations. Let's start with a simple kind of linear equation, the linear algebraic equation. And standard form is A times X equals to B, and A and B are given matrices like this. How can we find X? Well, we simply write that the solution to this kind of equation is like this. We can solve it, and we can use I and B to solve it. And if A is not invertible, then we can use P and to solve it. So this seems to be the solution of the original problem. However, in mathematical terms, it is not. And you can recall your memories of linear algebra. To solve this equation, there are three kinds of cases you must consider. One is the unique solution. When there is a unique solution, and how to solve it. The other one, infinite number of solutions. And the third one is no solution. So we can also follow the ways to discuss this kind of problem to solve linear algebraic equations. So let's consider first when this kind of equation has a unique solution. It has a unique solution if A minus A inverse of A exists, which means that A is a square matrix and it is a non-singular matrix. In this case, it will have a unique solution. So in mathematical terms, if M equals to A, where M and N are the rows and columns of A, M equals to N and the rank of A equals to N, then there is a unique solution. And unique solution can be expressed mathematically like this. And in Matlab, we have similar form. We have to invert matrix A and then multiply it by B. We can find the solution. And then we have to validate whether the results we obtain are correct or not, are accurate enough or not. Suppose we have a linear equation like this. This is the A matrix and this is the B matrix. So how can we solve that problem? What we need to do is quite simple. We can use commands like this. Let's consider numerical computation first. And by numerical computation, we can take the inverse matrix of A and times B, we can find the solution X. So our question is, what is the accuracy of X? So we should have A times X minus B, and it is a matrix. So the best way to check the error is to find the norm of it. And we may be very happy with the result because the error is quite small. And if you are still not satisfied with the result, what you need to do is to convert A matrix into a symbolic matrix, and then find the X again. And this should be the analytical solution to the original problem. And if we substitute the solution back to the original problem, we may see that there is no error in the result, and the matrix X is the analytical solution to the original algebraic equation. So for this kind of problem, there is no, if this one exists, then the equation will have a unique solution. This is the first topic. And when will the equation have infinite number of solutions? To solve this problem, we have to construct a checking matrix. For the matrix, we have the left-hand part is A matrix, and right-hand part is B matrix. We can compose A and B together. And this kind of matrix can be constructed in Matlab easily using a command like this. If there is an A and there is a B, we can construct a matrix C easily in Matlab. So, if we have already constructed the C matrix, and if the rank of A equals to the rank of C, then they are all smaller than the number of unknown elements. And then we say that this matrix have infinite number of solutions. So the question now is how to find the infinite number of solutions. To find the infinite number of solutions, we must recall the concept of basic set of solutions. If we can find the basic, I will explain that one later to you. If you can find the basic number, the basic set of solutions, then we can choose arbitrarily the constant alpha 1 through alpha n minus r, where r is the rank of matrix A. We can perform linear combination to the basic set of solutions, and we can get X hat. And no matter how you select alpha, the values of alpha, X hat is the solution of the homogeneous linear equation. So in this case, by selecting differently the values of alpha, we can construct infinite numbers of solutions to the homogeneous linear equation. And remember, our original equation is AX equals to B. Then, how can we find a particular solution, X node, satisfy this equation? To find it, we can use PINV A times B. We can find this equation. And if we add these two parts together, then we can get the infinite set of solution to the original problem. So we have two questions here. How can we find the basic set of solutions? The other one we have already constructed. How can we find the particular solution to this equation? So we can concentrate on how we can find the basic set of solutions. In fact, the basic set of solutions is the node space of A.